Hello guys, welcome to this tutorial. So in this tutorial, we're going to talk about bubble sort. Okay, what's bubble sort? So bubble sort is actually one of the sorting algorithm. Okay, that's one way to sort elements of an array of elements. It could be an integer or anything, right? Data structure and so on. So bubble sort is a simple sorting algorithm. Okay, so this sorting algorithm is a comparison based algorithm in which each pair of adjacent elements is compared, okay, and the elements are swapped if they are not in order. So this algorithm is not suitable for larger data sets, okay, as its average and worst time complexity are the big O of n squared. Of course, don't worry about that for now. We have not yet talked about the complexity, okay, the time complexity and so on. So just get it like this. So actually, how are we going to do that? First, we are going to implement the iterative method, and then in the next tutorial the recursive method. That's the divide and conquer, right? So how this bubble sort actually works now. So we take an unsorted array, right? Because remember that is one of the sorting method of an array of elements. Okay, could be a data structure, of elements or records and so on. So, and it's very important, because we need some time to arrange the elements of a given array in a certain order, so that we can better or optimize the search and so on. So let's go ahead and explain how this bubble sort actually works. Okay, so we take an unsorted array. Okay, for our example, let's just take something something like, let's just assume that our array contains something like 14, 33, and then we can just put 27, 35, and then 10. Okay, so let's just assume this. So bubble sort starts with very first with the very first two elements, comparing them to check which one is greater. Okay, so it's going to first check these two elements, that is 14 and 33. Now in this case, the value 33 is greater than 14, right? Okay, so it's already in sorted locations. Okay, that means we are assuming that we are sorting in the from the lowest to the highest. Okay, so 14 is less than 33. So now that is, we are done with this first check. So the algorithm we now, let me just put something like this. Alright, so that means we are done with the first check. Alright, now next we compare 33 and 27. Alright, so we are checking two pairs of adjacent elements, as you can see. So we take these two first, and then these two, and then these two, and so on. So next we check these two elements. Alright, so and we see that we find that 27 is smaller than 33, and these two values must be swapped. Alright, that means next, in the next line, what are we going to in the next check, what are we going to have? We are going to actually swap these two values, right? So then we are now going to have like this. That's the next iteration. Let me just put the first iteration so that you should not confuse that. So the first iteration we have this, and then because remember that 14 was is less than 33. So now the second iteration, that's how we are going to arrange the elements. Now this one is the new array. It looks like this. Now next we compare 33 and 35. We find that both are in already sorted positions. So that's how this one is actually okay for now, so we can skip these steps. So that means the next step, The next check we give out something like this, and then we move to the next two values, okay, that is 35 and 10. We know that 10 is smaller than 35, hence, okay, and not sorted. What are we going to do? We swap these values, okay. We find out we have reached the end of the array. After one iteration, the array, okay, one complete iteration, right, the final array will look, okay, something like this, right. Let me just arrange it so that you can, okay, something like this, okay. So if you count, we have 1 2 3 4 5, okay, and we have, okay, 5 iterations, okay, for the first check, right. Because what are we going to do? We are going to check that 5 times 5, okay, times, alright, because the size of the array is actually 5, so we are going to check 5 times 5. We have already checked 1 times 5, okay, times. So now we are going to check again for the second, okay, iteration. Now, to be precise, okay, we are now showing how the array should look like, okay, after each iteration. So now this one is the new, okay, the final array at the end of the first 5, okay, iterations. So the next first 5, remember that we have 25, that is the size of the array square, that's 25, okay. We have already iterated 5 times, so we need to iterate it again 20 times, okay. That's how the bubble sort actually works. So we are going, assuming that we have this as our new array, okay, this one, right. I'm going to create it, and then let me just replace it like this, okay. So this one is our new array after those first 5 iterations. So now we work on this, okay, because remember that we have iterated 5, okay, 5 times, and after that we are going to iterate 5 times, okay, 5 times, okay, the array, or the size of the array square, okay, that's 25. So we have already iterated 5 times, okay, that is go through the array 5 times. Then next we are going also through the array 5 times again, going 5 times again till, okay, we reach the 25 iterations. So this one is the new array. Next, in the next iteration, okay, what we are going to check again, 14 and 27 is already okay. So remember, this one is the 6, okay, iterations. Now 27 and 33 is okay, so it remains like this. So then next we check 33 and 10, we see that, okay, it's not in sorted order. So in that iteration we are going to have what, okay, we are going to have this 10 is going to, okay, come here. Then we are going to swap the two elements, okay, and now have something like this. Then we iterate again, that is checking this and this, okay. We see that is okay. So we are done with the, okay, with 10 iterations. We go next, okay, the next 5 iterations, okay, let's together the 15 iterations, and then we check again till, okay, remember that we are iterating, okay, we take 5 times, we iterate through the array, and then 5 times again iterate through, and so on, okay, till 5 times 5, which is actually the, okay, the array size square. So that's how it's going to iterate. So if you iterate those 25 times, the final array, as you expected, okay, as we expected, will look something like this, right. So you have the 10 here, and this will be, okay, our sorted array, okay, the final array. I hope you actually understand the concept. That's the concept behind, okay, the bubble sort algorithm and how it actually works, okay. In this case we are actually working with numbers, but in, okay, it may be anything that, okay, it depends on how you want to sort it and so on. So that's how it actually works. So this one will to sort for the less, okay, for the lowest to the largest. All right, now you can also sort from the largest to the lowest. All right, there's no problem. And then the philosophy is exactly the same thing. That means you are going to compare these two elements. Okay, if this one, okay, is less than, or in fact it's exactly the same philosophy. Okay, so let's go ahead and implement this using C++ programming, okay, language, and see how, of course, using the iterative method. All right, because in the next tutorial we are going to use the recursive or the divide and conquer approach to solve this, okay, for time complexity matter, as we are going to see later. So now in C programming we are just going to do something like this. Okay, of course, you should be familiar with this. Nothing, okay, strange here. STD we include the library and this, and then we are going to create our swap function. Okay, swap, just call it swap, okay, which takes what, two integer, okay, as in parameter. Okay, you can just call, okay, xp, or let's just say x. Okay, we are passing the value by, okay, reference, not by value, because, okay, we need to change and maintain that. Okay, it's not for, right? So we have here y, and then let's go ahead and implement that. Okay, we declare a temporary variable, okay, which is something, no, it's not strange. Okay, it's very straightforward. We just assign that x value to it. Okay, and then the y, okay, the x value is going to receive her, it's going to receive the y value. Okay, and then the y value is going to receive the cmp. Okay, as we expect. Then we are done with our swap function. Now let's go. Okay, we are going to use the use of this. Okay, we are going to see now. Let's implement our bubble sort function. Okay, it's better to implement function rather than, okay, implement it directly in your main program so that you can reuse it. Okay, it's very important, or it's a good practice to implement function instead of coding it directly in your main function. Okay, so if you want to, okay, let's just call it bubble, okay, sort, like this. Okay, just give the name bubble sort, which takes what, okay, an array, right, as we expected. Okay, as we expect now, and then the size of the array. All right, so we take the array and its size. Okay, now here we just declare two, okay, variables as we are going to use them. Now we just go through a loop. Okay, then for, okay, int, okay, I just call, we have already declared it, so we don't need this again. I like this, okay, less than what, n minus 1. Okay, the size of the array minus 1. Okay, I plus plus. Then what next? Now for, okay, again a for loop, right, because j from 0, what, yj is less than what, the size, okay, minus I, okay, minus 1, right, because as we are comparing, we are actually reducing. It's like we are reducing the size or the area to, not reducing the size, the area, okay, of the comparison. So that's why, okay, we have this. Okay, if you understood the philosophy as we implement earlier, then this should be very, okay, simple to understand. It's very important that you make sure, okay, that you have understood what we did previously. Then this one should be, okay, very straightforward. Right, now we can call that our swap function here. Okay, to swap the, okay, first we need to check if what, if, okay, array, right, if array of j, okay, is greater than, assuming that, okay, we are, okay, sorting, as you can see there, if the array of j, okay, is greater than j plus 1, okay, we swap them. That means we are actually implementing that our first, okay, program. Remember, from the lowest to the largest. Okay, If it's the case, then let us swap. Since we are passing by value by reference, then we need to do this, okay, array of j, okay, like this, and then again, okay, we swap the two elements, okay, then array of d plus 1, right? So that's how we are going to swap them, and then we are done with our swap function, right? So that's how it actually we can implement our swap function. Then let's go ahead and just we can even implement a simple function to print our array, because it's very important to have arrays instead of a function, instead of coding it directly into your main function. You can just have a function to print an array. You can just call it arrow, and then the size, of course, we take the size of the array that we can call m, then we just implement it, I, of course. So you can just go for use a for loop, where we take I from what, from 0, as we know, just to print the array, actually this, the size, which we call n, then I plus plus. So we have this, so we have to actually print, printf, what this, the percentage d, right? So here we have percentage d, which is actually the elements of the array, right? Percentage d, and then we space, then array of I, then that should be and then we can even put after that, we can just put the line, line break or something, go to the next line, right? Something like this, just for clarity. It's not that so important. Now we can actually go ahead and implement that our main function, right, to actually use our code and see how the things actually works. Now we have something, we can just have an array, something like this, which we can give elements here as 64. Let me just put something like this, so, and then just give the elements of the array as you want. I'm going to stop here. Alright, so those are the elements, and then we can have int n. Remember from our previous tutorials, size of size of what, of array, to actually get the size, divided by the size of word array of 0. It's good. From our previous tutorial, you're actually getting what we are doing here. There's nothing strange. And then we can just call our bubble sort on the array, and then passing n to the array, right? And then we can just say print sorted array, sorted like this. Sorted array is go to the next line, and then we are done. We can just call the function print print array, right? Just pass the array to the function and the size, and that should be right? And then we just return our 0 from the main function, right? So we have this implemented. Let's go ahead and test it and see. Normally everything should be right? As you can see there, we have sorted array. The elements are actually sorted. That's great, right? So hence we are done with the implementation of the bubble sort using the iterative method. Then in the next tutorial, we're going to talk about the recursive method or approach to solve the binary, the bubble sort, for time complexity matter, as we're going to see it later. Thank you guys for watching. See you next then. Bye. And also don't forget to subscribe. Hello guys, welcome to this tutorial. So in this tutorial, we're going to talk about bubble sort. What's bubble sort? So bubble sort is actually one of the